What's real? Can something we can't interact with in any way be real? Perturbation theory uses lots of really simple math put together to approximate really complicated math, which is useful because quantum mechanics is hard. Fun fact about empty space, it's not empty. Math says random energy spikes called quantum fluctuations are happening everywhere all the time. And because the Heisenberg uncertainty principle says certain variables like energy and time are mutually uncertain, and E
actually equals the square root of quantity rho squared c squared plus m squared c to the fourth.
There might be particles at a certain time at a certain place, or there might not be. Now let's bring it all back. Virtual particles are a way of making the math for quantum field fluctuations easier in perturbation theory by simplifying them into, yes, a pair of particles. Specifically, a particle and antiparticle that annihilate each other such a short time after appearing that we can't measure them, which is important because measuring how something breaks the laws of the universe, since creating something out of nothing violates conservation of energy, isn't allowed. Virtual particles mediate the strong force, weak force, and electromagnetism, so nothing more complicated than a quark could exist without them. Or could it? Lattice field theory says we can make the math for quantum field fluctuations easy and have fundamental forces by laying spacetime out onto a lattice. But wait, it gets weirder. By providing external energy so that the virtual particles don't annihilate each other, we can make real particles. Lattice field theory also allows this, but without virtual particles. So let's review. Virtual particles are a way of making the math for quantum field fluctuations easy, and exist for such a short time that we can't measure them, but we can make real particles out of them by providing energy, or make real particles out of something else. So, are virtual particles real? Maybe.